Hi, welcome to the video solution for Edexcel Physics. This is Edexcel IAL, Unit 2, January 2022. So let's start. Question number 1. The unit of power is the watt. Which of the following is included in the SI base unit of the power? So if you see this, there are lists given, and in watt, Newton, which is involved, but Newton is not SI base unit. Joule is not also SI base. Ampere is a SI base unit, but it is not involved in watt. If you recall, the formula for power, P is equal to energy or work done divided by time. And energy is joule and divided by time, which is in second. So unit of time is second. So joule is involved in the unit of watt, but joule is not SI base. Yes, joule is further can be written as Newton meter divided by second as it is. So watt can also be written as Newton meter second. Newton also involved in the unit of watt, but Newton is not SI base. So Newton cannot be our option. Now further, Newton meter can be written as kg Newton. Only Newton can be written as kg ms minus 2. And this is the second meter here, divided by time. Finally, if you see, you can finally simplify kg meter square s minus 2, and this has is coming up, so total minus 3. This is SI base unit of watt or power, equivalent to watt. So kg is involved as a SI base unit in watt. So option must be B. Question number 2. The diagram shows a combination of three resistors of resistance X, Y, and Z. And this is circuit diagram given. Which of the following gives the total resistance of this combination? Because values are not given, we need to write general expression for total resistance. Clearly, Y and Z, these are two resistances in parallel. So first we figure out combined resistance of X and Z. They are in parallel. Remember, in parallel, the combined resistance is R1, R2 divided by R1 plus R2. This is the formula for combined or total resistance of two resistances in parallel. So if you apply this approach to X and Y and Z, so the combined resistance of these two will be YZ over Y plus Z. And this is the combined resistance of these two, and this new combined resistance with X are in series. So the total resistance along with X will be X plus YZ over Y plus Z. So if you see, C is the option. Question number 3. Ultrasound can be used to investigate organs inside the human body. Which of the following statement about ultrasound is correct? All of the ultrasound is reflected at the boundary between the different tissues. No, some is refracted as well. Ultrasound travels faster in air than inside the body. There's nothing to do with the speed. Ultrasound with greater wavelength gives an image with higher resolution. No, this is opposite. Greater wavelength gives low resolution, so we need low wavelength or small wavelength, high frequency. Ultrasound with shorter pulse duration gives image with high resolution. This is correct, because a small duration or shorter pulse can gives image with high resolution. The reason is if this is some object from which the ultrasound is being reflected. So shorter pulse means the pulse will come and return quickly before moving on to the next space. So shorter pulse mean every minor detail can be obtained from this shorter pulse duration. So D is the correct for ultrasound imaging. Question number 4, electromagnetic radiation can be described in terms of photon model. Which of the following demonstrate photon model of light? Diffraction pattern, Huygens construction. These two are wave behavior, not a particle behavior. Plane polarization, this is also wave behavior. Photoelectric effect is the only option in this, which can be explained only with the help of photon model or particle model of light. So option is C. Five and 6 refer to the following informations. The diagram shows a circuit used to determine the internal resistance R and EMF of the cell. Typical circuit of EMF of the cell: EMF, internal resistance R, voltage V, current and variable resistor. Corresponding values of potential difference V and I were taken after adjusting the variable resistor. A graph of V against I was plotted. Which of the following is correct? The area under the graph, there's nothing to do with the area. The gradient of the graph is R. No, it is not R. It is in fact minus R, negative, because in this case, if you plot V against I, so you can have a straight line with negative gradient. So if you find the gradient, then gradient would be equal to negative of R. And the y-intercept, if you extrapolate the line, and then here, this is the EMF, a typical 2 calculation gradient. From gradient, we can find internal resistance, and y-intercept gives us EMF. So A and B cannot be our option. The graph shows directly proportional. No, it is not directly. Clearly, you see that they are not directly related. Current increases, voltage decreases. The y-intercept, yes, D is your option, because y-intercept is your EMF. Question number 6, from the same condition, same situation. The resistance of the variable resistor is R. Which of the following gives current in the cell? A typical question, again, is straightforward and easy question. You need to find which expression will give you current in the circuit. So if you recall, your typical equation is E is equal to V plus IR. And this V is the terminal potential difference or voltage across the internal resistor. Here, same. This V and this V are the same. So this V can be written as IR plus IR. And then I is common. So R plus R. So current will be EMF divided by R plus R. Option is C. Question 7, a graph of displacement against time for a point on transverse progressive wave is shown. Displacement and time, remember this is time axis here in second. Which of the following statement is correct? The amplitude of the wave is 20 centimeter. No, we cannot say amplitude is not 20. Amplitude is in fact measured from the equilibrium position. So this will be the amplitude, which is 10, not 20. So this is wrong answer. The frequency of the wave is 2.5 hertz. Yes, indeed, this is the correct option. I will show you, but let's discuss. See, the period of the wave is 0.2. No, it is not 0.2, because period is all about one cycle, one wave. And one wave is completing from this position till this position. So this 0.2 is basically wave for half of, half of the wave, time for half of the wave, not for full wave. So this is wrong. The wavelength of the wave is 0.4 meter. We cannot determine wavelength from the given information, because this is displacement time graph. Unless we have a speed, then we can find wavelength. Otherwise, wavelength cannot be said that it is 0.4. Now, how is it B? We know that the time period T is time for one wave, which is one wave completed from this position till this here. This is one wave. And if you see, the time given in the graph is 0.4 second. So frequency will be 1 upon 0.4. So frequency is 2.5 hertz. So B is your correct option. Question number 8. A ray of light travels through glass towards a boundary between glass and air. The critical angle of this boundary is 42 degree. Which row of the table is correct? 40 degree, if angle of incidence is 40 degree, all of the light is refracted 40 degree. No, both are wrong. Don't waste your time. The reason is, if angle is less than critical angle, which is 40 degree, both are less than critical angle, because they are saying critical angle is 42. So 40 degrees less than critical angle. Practically, all incident angle less than critical angle, we always have refraction and reflection both at the same time. So we would have both. So A and B cannot be our option. And 45 degree is critical angle greater than, 45 degree is the angle of incident greater than critical angle. And at that moment, we have total internal reflection. So we cannot have a refraction, but total internal reflection. All of the light is reflected. Total internal reflection. Option is D. Question number 9. In 1924, de Broglie suggested that electrons have wave properties. The de Broglie equation states lambda is equal to h upon p. Which of the following is correct? The de Broglie wavelength is independent of the mass of the particle. No, because this equation for a particle wavelength can be written as lambda is equal to h upon mv, where m is mass of the particle and v is the speed of particle, speed of the particle. So p is the momentum of the particle. So this is not, the de Broglie equation can be used to calculate momentum of the photon. Yes, this is the correct option. Reason is h is the Planck's constant. If we use wavelength of photon, then p can be found h upon lambda. If lambda is the wavelength of photon, then we can find the momentum of the photon. So B is our correct option, but let's discuss C. The term P represents the mass of an electron multiplied by speed of light. No, P is the momentum, which is the, if we are dealing with the particle, then we should use speed of the particle, not speed of light. The value of H depends on the particle involved. No, H is a constant. It does not depend on the particle mass or with speed, whatever. So of course this is wrong. So only option is B. Question number 10. In a series circuit 3.1 10 to the power 19 electrons pass a particular point in time 30 seconds. Which of the following gives magnitude of the current in ampere in this circuit? Easy, straightforward question. You just need to find the current if these electrons are given. General concept is current is charge divided by time. There is a confusion. Sometimes students think that this is the charge. No, this is not the charge. This is number of electrons. So Q, that you need to find the charge. So Q is number of electron 3.1 into 10 to the power 19 times amount of charge on one electron 1.6 10 to the power minus 19 divided by time, which is 30. So option is A. Question number 11. A copper wire of radius 0.4 millimeter carries a current of 5.1 ampere. Calculate the drift speed of electrons in the wire. Number of charge carrier per meter cube of copper is this. Again, easy, straightforward question. If you remember the formula for drift speed, so drift speed can be found by transport equation. I is equal to NA Q or EV. Sorry, EV. This V is the drift speed. Q can be replaced with charge of electron. So drift speed V is equal to I over NAE. That means we need to find first area of the wire. So area of the wire A is equal to pi r square. Radius is given. So pi into r square, 0.4 into 10 to the power minus 3, because it is in millimeter, whole square. So area A would be equal to 5.03 10 to the power minus 7, and then drift speed is equal to 5.1 divided by n is charge carrier density, so 8.5 into 10 to the power 28 into area, which is 5.03 10 to the power minus 19, minus 7, yes, into charge of electron, 1.6 into 10 to the power minus 19. So drift speed would be equal to 7.46 into 10 to the power minus 4 ms minus 1. Question number 12. A student investigated the superposition of water waves in a ripple tank. There are two sources of waves, S1 and S2, which are in phase. This is important information. Both waves are in phase. The diagram shows the position of successive crests of each wave at any instant in time. Explain the type of superposition taking place at position A and B. Now, before giving answer, you need to understand the meaning of wave fronts that you see. So any wave is represented in the way of that we draw either a straight line or a curve in this case. So each solid line that you see, each lines shows crest, or you can say trough. It's your choice. So if you generally we say crest, but you can take them as troughs as well. But easy way is crust. So this is the crust, this is followed by the next crust and then another crust and so on. That means in between two solid lines, we don't show, but we know that between two crusts there has to be trough. So in between there is a trough for each wave, because transverse wave moves in the form of crust followed by the trough. If you see this is the generally wave. So this line is showing all the points here, and the second one followed by this, and in between two crusts we always have a trough. So these dotted line, for your understanding, I'm drawing to show that there are crust or trough in between each two solid line, something like this. So if you now, let's come back, position A. If you see position A, this is the crust of one wave and crust of the same wave. In between, we have troughs. So we have a trough, and we also have a trough of this wave, something like this. If you see, so at point A, we have a trough combining from both waves, and waves are in phase, so there will be a constructive interference. So at A we have constructive interference because trough of one wave overlaps or combined with trough of the other. While at B, clearly you see you have a crust coming here and you have a trough B. So at B we have a crust of one wave combining trough of the other, and waves are out of phase, so we have destructive interference. So A we have constructive minima, and B we have destructive interference. And reason I have already given you, so that's how you can write your answer. A student investigated how light intensity affects the resistance of a light-dependent resistor LDR. She set up a circuit using a cell with negligible internal resistance as shown. The EMF of the cell was 1.5 volt. When the light is in the laboratory were switched off, the voltmeter reading was 1.19. calculate the resistance of the LDR. So this is again a typical question of finding voltage or resistance from a potential divider circuit. So for potential divider circuit, we have a ratio between voltages V1 upon V2 is equal to R1 upon R2, or vice versa, or you can flip the whole fraction on the both side. So let's consider this is the resistance of the resistor. Let's call this R2, and that means the voltage shown here, which is V2. So of course we can figure out V1. So V1 would be equal to 1.5 minus 1.19, which is 0.31 volt. This is the voltage across LDR. Now R2 is equal to I call them R2, R1. R1 is equal to R2 upon V2 into V1. So 5000, which is R2, 5 K is 1000. 5000 into V1, 0.31 divided by V2, which is 1.19. So R1 is equal to 1.3 10 to the power 3 ohm. This is the resistance of the LDR when the light was switched off. Part B, when the light were switched back on, the student discovered that it was impossible to calculate the resistance of the LDR using the circuit. The teacher said that with the light on, the resistor of the LDR was about 9 ohm. Explain why the student was unable to use that given circuit to determine the resistance of the LDR with the light on. The resolution of the voltmeter is 0.01. So idea is, because resolution of the voltmeter is given, so we find what is the voltage across each component when the light is turned on and the resistance of the LDR is 9 ohm. And then we compare whether this voltage can be measured with the help of given voltmeter or not, or given circuit or not. So let's we found the voltage across the resistor, which is V2, when the light is on. So when the light is on, V2 will be R2 divided by R1 plus R2 into the power source voltage or EMF. So R2 is 5000 divided by R1 plus R2. So 5009 into 1.5. And if you see V2, when the light is turned on, is 1.497 volt, which means V1 voltage across LDR is 1.5 minus 1.497. V1 is equal to 0.003 volt, and so V1 is much less than the 0.01, which is the resolution of the voltmeter. 0.003 is less than 0.01, which cannot be measured. So it cannot be measured from the given voltmeter. Question number 14. The diagram shows some of the energy levels for an atom of hydrogen. Energy levels of hydrogen atom when an electron with kinetic energy of 12.3 electron volt interacts with this atom. An electron of the atom moves from 13.6 minus 13.6 to 1.5 electron volt. But when photon with the same energy, with the energy of 12.3, when the photon with the photon energy of 12.3 electron volt is incident on this atom, electron in the atom stays in the shell, in the same shell. Okay. So the idea is, when an electron is coming with the energy of 12.3. So imagine this is the electron inside the atom, and an electron is coming from outside, and this electron has energy of 12.3. An electron is incidenting or hitting with this electron. So what happened if you find the difference between energy level of 1.5 and 13.6? So energy difference will be 1.5 minus of minus 13.6. The answer will be 12.1. That means out of 12.3, 12.1 is transferred to that electron. So the electron can jump exactly to the shell of energy minus 1.5. And the incident electron still has some remaining energy. Remaining energy 0.2 electron volt, and it keeps moving with that energy. So yes, electron can transfer. But instead of electron, if a photon of the same energy, 12.3 electron volt is coming, and this photon is colliding or interacting with that electron. So photon always transfer all of its energy to the electron. So this, in this case, this electron is going to receive not 12.1, but this electron is going to receive now 12.3 electron volt of energy. And if you can use your calculator, there are no two shells which have an energy difference of 12.3. So even after absorbing the photon, electron cannot move in any of the other shell. This is not 13.6. Energy difference of 12.3. Electron will receive 12.3 of energy, but there are no two shells which have energy difference of 12.3. You can use your calculator to figure out. I'm sorry about this typo. Question number 15. A physics teacher placed a coin at the bottom of a cup. When viewing the cup from an angle, the coin was not visible as shown in the photograph 1. There is a coin inside, but we cannot see. While still observing from the same angle, the teacher slowly poured water into the cup. The coin gradually becomes visible as shown in the photograph 2. Now we can see, after pouring water, we can see the coin here. This effect is caused by refraction. Explain what is meant by refraction. So refraction is a transmission of light from one medium to another medium, and due to difference of density, wavelength and speed of the light or the wave changes, and this effect is called refraction of light. Part B, the simplified diagram below shows how a ray of light travels from the edge of a coin to the teacher's eye when the cup is partially filled with water. Determine the refractive index of the water in the cup. And we are given, if you see the diagram, we are giving some distances: height of the cup, height of the water in the cup, and the positions of the coin from the edge of the cup. The idea is, if you need to find the refractive index, you need either speed of light, which are not given, of course, or angle. In this case, first we need to figure out angles, angle of incidence and angle of refraction. So this is incident angle, I. Clearly, if you see, we have a right angle triangle. This is opposite, 1.8, and this is adjacent, 3. So we can use tangent I, opposite over adjacent. So 1.8 divided by 3.0. So you can figure out I if you use tangent inverse. So I incident angle will be 30.96, which is, you can say, I is approximately 31 degree. Similarly, you need to find refracted angle. This is angle R, because ray is coming into air. This R. And in order to find this R, we are going to consider the triangle. So this R is same as this angle R. Again, this is opposite. This side is opposite side, which is 3.7 opposite, and this is the adjacent side, which is the no, not the total, this much. Yeah, this is 4 adjacent. So we can use now tangent R, refracted angle, is equal to 3.7 divided by 4, and R would be equal to 42.96, which is 43 degree. Now you have angle R, you have angle I. It is refraction from denser to rarer medium, so you can use N is equal to sine of R divided by sine of I. So sine of 43 divided by sine of 31. So N is equal to 1.32. This is the refractive index. Thank you very much. I hope you understood every concept. Let me know in the comment section. And you can visit these website for notes and the worksheet. Have a nice time.